This question says that you want to find the equation of the line that is perpendicular to the line, this line, 7x minus 2y equals 8, and it passes through this point. So the first thing you want to do is solve this equation, 7x minus 2y equal 8. Solve it for y. So if we solve it for y, first of all I subtract 7x from both sides, and then we divide by negative 2. And so we end up with y is equal to negative 4 plus 7/2 of x. So this is what we're interested in. This is the slope. But we want the perpendicular slope. So the perpendicular slope is the negative reciprocal of 7/2, which is negative 2/7. So then we use the slope point form to find the equation of a line. That's the slope point form. It says y minus y1 equals m times x minus x1. So y minus 2 equals negative 2/7 times x minus a minus 3. So we just do some simplification. Y minus 2 equals minus 2/7 of x. This is going to be a plus 3, but times a minus 2, that's going to be a minus 6/7. And then if we add 2 to both sides, we get y equals negative 2/7 x, and 2 is the same as 14, so you'd have plus 14/7. Sorry, 2 is the same as 14/7. So plus 14/7 to both sides, so minus 6 plus 14 is 8/7. So that's the equation of the line. Now, if it says you want it in general form as well, in general form you multiply the whole thing by the denominator, which is 7. So you multiply y times 7, so you get 7y. You multiply this by 7, you get minus 2x. And you multiply this by 7, you get plus 8. And you rearrange it however you want to. If we put everything on one side of the equation, we get 7y plus 2x minus 8 equals 0. And that would be the general form of that linear equation. But note this one is valid as well. This is the slope-intercept form of the linear equation. Alright, this problem says you want to find the equation of a line that joins the centers of these two circles. And there's two circles we have here. X squared plus 8x plus y squared plus 2y plus 13 equals 0. And we have another circle, x minus 1 squared plus y minus 7 squared equals 17. So we want a line that's joining these two circles. So this is a circle, this is a circle, they both have centers, and we're going to draw a line through the 2 points. What's the equation of that line? So without even drawing it, we can do the algebra, because I know right from this one that the center of this circle here is 1, 7, and the radius, which is really not necessary for this problem, but it's good to know the radius is the square root of that 16, which is 4. Now this equation is not written in that nice form where I could read the center right off. So we have to complete the square. So the point of this problem is for you to be able to complete the square. And once you do that, you can find the center. So what do we do to complete the square? Well, I'm going to rewrite this as x squared plus 8x, leave a space, plus y squared plus 2y, leave a space, and I'm going to move this 13 over to the other side, so I'm going to subtract it from both sides. Then I take half of the number with the x here, which is 8, half of that is 4, and I square it, and I'm going to add that. Square root of 4 is 16, so I have to add 16 to the right side. Similarly, I'm going to do next to the y, there's a 2, half of that is 1, 1 squared is 1, so I'm going to add a 1. So what do we have here? The reason I do this is because now I can now factor each of these, with the thing with the y's and the thing with the x's, and this factors into x plus 4 times x plus 4, so that's x plus 4 squared, and this other one factors into y plus 1 times y plus 1, which is y plus 1 squared. So you can check that, make sure you can factor these two, but by design they factor into these nice things that are squared, because these are perfect square trinomials. And on the right side I have negative 13 plus 16 is 3 plus 1 is 4. So right now I could read right away that my other center is located at -4, -1, right? The opposite signs of whatever's attached to the x and y, and the radius is equal to 2. So now we want the line between the two centers. We have 1, 7 and -4, -1. So how do you find the equation of a line? So there's one center and here's another center. The equation of a line just requires 2 points, right? And first we have to find the slope between the 2 points. M is the slope. Remember, M is y2 minus y1 over x2 minus x1. So y2, let's call that 7. 7 minus minus 1, 7 minus minus 1 over 1 minus minus 4. 1 minus minus 4. Remember, keep your orders correct. If I'm using this as y2, then x2 is here as well. Okay, so that gives me 8 over 5. Okay, so my slope is 8/5. And then we can use that point slope form again. Y minus y1. Let's use the center 7. Y minus 7 equals 8/5 times x minus 1. Right, and you might want to simplify it a little bit. So y equals 8/5 x. Then you'll have minus an 8/5, but then you're going to add a 35. So 35 minus 8 is a 27/5, and I did that fast, but you can check that. But there's my equation of the line right here. So this problem, we want to find the equation of a circle that has these 2 points as endpoints of the diameter. So we have 2 points, and the idea is if you have one -4, 1 here, and -2, 8 up here, let's say, they form a circle. Well, the first thing to recognize is that the distance between them, if they're endpoints of the diameter, the distance between them is the diameter. And so we can find the radius by taking half of that. And the second thing is the middle of them is the midpoint. So what we're going to do, as I make this thinner, what we're going to do is first find the center. Well, the center is you find the midpoint of these 2 points. So the center is -4 minus 2, like the average of the x's, over 2, and the average of the y's, which is 1 plus 8 over 2. So the center is occurring at -4 minus 2 is minus 6 over 2 is minus 3, and then 1 plus 8 is 9 over 2, 9 halves of 4.5. That's the center. The next thing we want to know is what is the radius. So the radius is the distance formula over 2. So I'm going to put this over 2. So the distance formula says take the difference in the x's, so you get minus 2 minus minus 4, and square that, plus the difference in the y's, which would be 8 minus 1, and square that, and you do some calculation. Here you're going to have minus 2 plus 4, so that's 2 squared is 4, and then here you'll have 8 minus 1 squared is, that's 7 squared is 49, so 4 plus 49 is 53 over 2. So that's my radius. So if you want the equation of the circle, you just go x minus the x coordinate, so that's x minus minus 3, which becomes x plus 3 squared, plus y minus 9 halves, y minus the y coordinate squared, equals this number, 53, root 53 over 2 squared. Well, when I square that, on the top I'll have 53, on the bottom 2 squared is 4. So that's my equation of the circle. So the next question says, state the domain and range of the circle. So this is an interesting question. It's getting you to think about the domain and range of, there's this circle, it's a picture of this circle, and here's the center. But think about it, the domain then is going to be all the x values, which is really, from the center I go out one radius to the left and one radius to the right. I get all the x values that I can possibly have for that circle. So my domain is going to go from whatever my center is. Well, my x coordinate of center is -3, and I'm going to subtract off the radius. Well, I just approximated the radius as 3.64, so that's 3.64, and whatever that is, and then you're going to go to -3 plus 3.64. So think of that. That's the domain of my circle. And similarly, the range of this circle is a similar idea. I'm going to start with the y coordinate and go down a radius and up a radius. So my range of this circle is 9 halves minus 3.64 and 9 halves plus 3.64. So you have a domain and range of this circle. Those are all the x values and all the y values that are possible in this circle.